we're going to start with the heart of algebra, word problems, and function interpretation. And word problem means that we have some problem that is written down in words. Okay, we have some problem. We have a mathematical problem that is written down in word, and we need to solve it. We need to solve it by using our concepts of algebra, concepts of geometry sometimes in the geometry section. Maybe we will also see some similar type of problems. So before we are starting the word problems, that is basically we just need to know what the basic that we just need to know the basic thing. For an example, wording examples for common mathematical operation. Wording examples for common mathematical operation. They're saying that is, are, was, were, will be, equals, gives, yields, result in, cost, sells for, is, equal. We will use the equal sign. And I don't think that's a very good way. That's a very good way to memorize these phrases, or memorize these words, what we are gonna do, what we are not gonna do. But rather than grow, just try to grow up an intuition. Just try to grow up an intuition when you need to do what kind of operation. For an example, sum plus increased by, more than, together, combined, totals, added to, greater than, older than, further than. I think these type of words and phrases are clearly indicating you to do the adding operation or the
Yeah.
summing operation. So these things are really necessary, but this thing will try to help you to grow up an intuition, but you don't need to memorize them, because if you really try to memorize them, it's really not possible. Difference, decreased by, less than, fewer than, minus, after, leftover, younger than, shorter than, smaller than. We will do, in these cases, we will do the subtraction operation, or we will do the minus operation. And multiplied by, times, of, product. It's a very important word, of and product of, because of is a very useful word in the case of mathematics, when we are just trying to do some multiplication operation. Multiplied by, times of. You will understand whenever we are just going through the problems, the word problems, hands-on word problems. Product of, twice, triple, quadruple. We use this case. We use In these cases the multiplication operation, divide by, par, out of, split, average, ratio of, half of, one third of. We use the division operation. So, uh, do you understand these things or not?
Yeah. Yes. I
Okay.
know this.
Okay, all right. So let's try with a very simple problem. That is our example number one. Translate this sentence into an algebraic expression. So this is the word problem exactly look like. Translate this sentence into an algebraic expression. So word problems mean that you just need to you just need to use the concepts of algebra. Definitely you just need to concepts of algebra. And you just need to use the concept of basic arithmetic. And you just need to give a structure of algebraic equations, maybe linear equations, maybe quadratic equations, and then you just need to solve the algebraic problem. Then you will find out the problem, the solution, the answer of the problem. There's a total of 40 pages at a store with X dogs and Y cats. Translate this sentence into an algebraic expression. There are a total of 40 pets at a store with X dogs and Y cats. So I think it's very simple that they're indicating that we have X number of dogs and we have Y number of cats, and
Mm.
the total number of dogs and cats is equal to 40. So this is it. X plus Y equals 40. Do you understand this? It's a
Yes.
child problem, I think. Okay.
Yeah.
So this time, example number two, translate these sentences into algebraic expressions. Caitlin is 6 years older than Alison, and the sum of Alison's age and Caitlin's age is 6 years. Okay, Caitlin. Okay, so one of the most important thing whenever you're just going through any kind of problem is just by reading that problem again and again. You just need to read the problem again and again. And for an example, if you really don't understand the statement by
Mm.
reading it once, then you should definitely read it twice. Definitely, you should definitely read it um, multiple times, as many times as you really need to do. Okay, so um, Caitlin is 6 years older than Allison. Caitlin is 6 years older than Allison, and the sum of Allison's age and Caitlin's age is 6 years. So you just need to think how you can solve this problem. For an example, you just can subtract the subtract their age or uh, I think that's the basic. For an example, if you just think that Caitlin's age is C and Allison's age is A, okay. So one of the most important thing, okay, I'm not, I haven't seen that they're using the C, but I'm telling you that is actually I haven't seen the solution yet, but I am just thinking from my brain, and they are just using the same notation and the same convention because they are indicating A. They're
Mm.
indicating Allison's age by using the letter A, alphabet A. Okay, so why you are using the alphabet? Can you tell me that?
The alphabet A.
Oh, okay, I'm just asking
Wait,
you why they are
yeah,
using the alphabet A for Allison's age.
to like use it as an X value
To use as an X value. Okay, fine, but why? Can you please tell me a little bit more?
to find Allison's age.
To find out Allison's age. Yeah, but the thing is, actually, we are just indicating A. We are just indicating Allison's age by using the letter A
Yeah.
because it's very helpful or it's very convenient to 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 make you understand that A is for Allison and C is for Caitlin. A is for
Mm.
Allison and C is for Caitlin because the first letter of Allison is A and the first letter of Caitlin is C. So it's very convenient to use the letter A and C rather than using instead of X and Y. It's really helpful because it will really make you understandable easily because A is representing Allison and C is representing C. We can also use X, we can, if you wish, you can use X for Allison's age and you can use Y for Caitlin's age, but that would not be that much convenient as
Mm.
A and C. You got it, right?
Yes.
And in most of the cases where if you just study physics or chemistry, you would see that they are just representing the variable, the notation for the variable as the first name of the variable. For an example, we have we have we have a variable called work. So to represent work in physics, we use W, and to represent energy in physics, we use E. So these are very convenient to use the first letter of the variable's name. So I hope you got it, and that will really help you to break down the problems because you can
Oh,
easily figure it out
yeah.
what thing is representing what variable is representing what. So you can just easily subtract their age because Caitlin is 6 years older than Alison. So Caitlin
Mhm.
is older. So the age of uh, so the Caitlin is 6 years older than Alison. So if you subtract subtract Allison's age from Caitlin's age, the number would be 6.
Mhm.
If you subtract Allison's age from Caitlin's age, the answer would be 6.
Yeah.
Okay,
Oh, wait.
and the
Okay.
sum of Allison's age and Caitlin's age is 60 years. So it means that C plus A equals 60.
Yeah.
Okay, it's very easy now to find out the answer, find out the age of Caitlin and Allison individual because this is just nothing but some linear equation. This is a linear equation, and this is also a linear equation. So we can solve this equation, and we can find out the age of Caitlin and age of Allison. You got it or not?
Yes, I got it.
Okay, thank you. Now, next, move to the next problem. A stoplight is always green, yellow, or red. It is green 3/5 of the time and yellow 1/4 of the remaining time. What fraction of the entire time is the light red? Okay, I'm telling you again and again. I'm telling you again and again. You really need to read the statement, the problem statement as much as the same as many times as you really want to read it before you are understanding the problem statement. You just need to go through the problem statement maybe twice, maybe 3 times, or maybe 4 times, but you really need to understand the problem statement. Because if you really don't understand the problem statement, then you won't be able to construct some linear equations or whatever it is. So I stoplight is always green, yellow, or red. A stoplight is always green, yellow, or red. It is green. Some people say that the art of solving word problems is by reading it again and again. The art of solving word problems is just by is the art of reading a word problem. Some people say like this. My father used to tell that. So okay, it is green 3/5 of the time and yellow 1/4 of the remaining time. What fraction of the entire time is the light red? Just just give me an overview. You just need to tell me what thing you can do. Just give me an overview.
Um, you can set this up.
Sorry. Can you please tell it
Set up,
again?
set it up in an equation.
We can set up an equation, but how can we set up the equation?
Mm, like red equals like 3/5 and 1/4.
Okay.
Sorry.
Okay. It is green 3/5 of the time and yellow one
Yeah.
four of the remaining time. It is green 3/5 of the time and yellow 1/4 of the remaining time. So,
Yeah.
what fraction of the entire time is the light red? So, we can understand or we can think that because basically a stoplight is consisted of three different types of light: the green
Yeah.
light, the yellow light, and the red light. So, the green is the 3/5 of the time. So we just need to represent or consider the whole time as a variable. We just need to think of t variable, and we just can introduce a new variable of the total time that can be t, and it is green 3/5 of the time. So
Mm-hmm.
the green light time period is 3/5 of t. You can just think like this. I really don't know how they have solved the problem, the book, the author, and I'm just thinking in this way because you also need to grow up an intuition like this. Because not all the time, maybe because not all the time, the problem stated in this case would not be the same as the solution, as you are preferring the solution. But the answer is maybe right. But so how to think, because I'm telling you how to think about the problem. So, and yellow 1/4 of the remaining time. It is green 3/5 of the time and yellow 1/5 of the remaining time. What fraction of the entire time is the light red? So you can also write 1/4 t, 1/4
Mm-hmm.
t. Okay, not 1/4 because the remaining time, the fraction of the entire time is the light red. Because if you sum this green light time, the yellow light time, and the red light time equals
Yeah.
t. So that would be t. So green light time 3/5 of t and 1/4 of t. And let's see what they are using. Okay, for an example, they're just okay. They're not using any kind of variable. So okay. Read the solution one step at a time, writing out the relevant information. Since the stoplight is always green, because they are not basically using any kind of algebra. They're just solving this problem by using common arithmetic.
Okay.
We can determine the fraction of time it is not red by subtracting the green, yellow, and red. We can determine the fraction of time it is not red by subtracting the green, yellow, and red fractions from 1. Yes. Yeah, okay, yes, exactly. So you can also solve it. That would be an homework problem for you, but the thing is, consider the whole time as equals 1. The whole time. You
So
can
every
consider, sorry,
yeah.
you
No,
can
so
consider
like
the whole,
yeah.
you can consider the whole time as t. So it
Mhm.
is green 3/5 of the time and yellow 1/4 of the remaining time. What fraction of the entire time is the line? Red. So
So all of that would equal to 1.
all of them is equal to 1. All of them
Okay.
will be equal to 1. So if you add this green time and the yellow time and subtract it, the summation of green time and yellow time from 1, then you would get the time for the red light.
Okay.
You got it or not?
Yes, this
You can
yes.
also write it as a linear equation. You can also write it as a linear equation of one variable. For example, if you really want to introduce a variable red for the red light R, then you can just write it the 3/5 plus 3/5 plus 1/4 plus R equals 1. Actually, that is the same as we have just added the green light time and the yellow
Um,
light time, and we have subtracted it from the 1.
yeah, okay.
Okay.
Yeah.
So basically, they have just done it maybe the same. So use at least one common denominator. Actually, they are just trying to uh, telling you the exact step-by-step solution. Okay.
Mhm.
Okay. So and fraction from 1, the remaining fraction will indicate the fraction of the time is red. The green time, the time would be remaining time. Okay. Yes. Okay. Actually, they have just done the same because 3/5 plus 1/4. 3 by 1 3/5 minus 1/10. Okay. Um, you can also use the algebra. I'm preferring you to use the algebra because I think they're just complicating. Okay.
Mhm.
You can try it. If you don't understand the problem, then you can call me. But I think you can all use the algebra because I think they're just complicating it without any kind of reason. Multiplying it, I don't know what they're doing.
Mhm.
Okay. Um, Turn these sentences into algebraic expressions. Pam read 40 pages of her book on Monday, 30 pages of her book on Tuesday, and X pages of her book on Wednesday for a total of 120 pages. Pam read 40 pages of her book on Monday, 30 pages of her book on Tuesday, and X pages of her book on Wednesday uh, for a total of 120 pages. Can you please tell me how to solve this problem?
Okay. 20 books on Monday, 30 on Tuesday. So it would be 120. Wait. Okay, so 120 equals the Monday plus Tuesday plus X.
Yeah, exactly. Now, problem number 2. If Yusuf did 1 hour of homework on Sunday and twice
Mhm.
as you have done the problem one correctly, practice problem one correctly. Now go to problem number 2. If Yusuf did 1 hour of homework on Sunday and twice as much homework on Monday, how much? How many hours did he do on both of those days?
Okay, so
If
total would be 1 hour, and since you
mm,
said twice, that would be multiplied by the Monday,
if
right?
Yusuf did 1 hour of homework on Sunday and twice
Yeah.
as much of homework of Monday,
So one times n for Monday, right?
mm,
No.
on Sunday Yusuf did 1 hour and
Yeah.
twice as much homework on Monday. So
Times
uh,
t.
uh, I think you just need to add them. 1 plus 2 equals
Oh,
3 because Yusuf did 1 hour of homework on Sunday. Sunday he did 1 hour of homework and
right.
twice as much homework on Monday and twice as much homework on Monday. Okay, so twice means you have just done basically you used to have done 2 hours of homework
Mm-hmm.
and
Oh,
in total 1 plus 2 equals 3 hours maybe I think That is the
Yeah.
solution,
Yeah, I
if
get
I'm not
it.
wrong. Yeah, total 3
Yeah.
hours of solution. Dog X, I'm sorry. Dog
Mhm.
X is 5 years older than dog Y. Dog X is 5 years older than dog Y. This is a very common problem. I think you would understand. Sophia spends two-thirds of the 24 hours in a day awake. How would you calculate the number of hours age she is asleep in a day? Sophia spends two-thirds out of the time, 24 hours in a day awake. Sophia spends two-thirds
Mhm.
of the 24 hours. Two-thirds means the first of all, you just need to simplify the problem. 24 hours, two-thirds of the 24 hours. Two-thirds
Mhm.
of the 24 hours. Two-thirds of the 24 hours in a day awake. So the time she is awake, that is basically two-thirds of 24 hours. 2 by 3 into 24. 2 by
Yeah.
3 into 24. How
Yeah.
would you calculate the number of hours she is asleep in a day? So the total number of uh, hours in a day is 24 hours, right?
Yeah.
So if you can somehow manage to find out the time that she is awake, then you could definitely find out the hours she is asleep.
Yeah.
So that okay, so uh, you can solve this problem in two methods. You can solve this problem into two methods. Okay, the first thing is the first method is you can take two-thirds of 24 hours and you would get an answer. You would get an answer, and then you can subtract the answer from 24 hours.
Wait,
Okay,
what?
okay, I'm telling it again. So two-thirds of the 24 hours in a day awake. Sophia
Mhm.
spends two-thirds of the 24 hours in a day awake. So the amount of time she is awake in a day, that is basically two-thirds, 2 by 3, 2 divided by 3 into 24, right?
Yes.
2 divided by
Wait,
3
divide it
into
to.
24. She is awake.
Oh yeah. Okay. Yeah.
So you would get an answer from that. You would get an answer from that.
But how would you do that? 2 by 3.
2 by 3 into 20. Okay. 2 by 3 into 24. It's just a simple math. 2 by 3 into 24. 2 divided by 3. 2
Mhm.
divided by 3 into 24.
So would you like? Sorry, divided by 24? I know it's two third, but like, sorry.
Okay, so you are just concerned about the fraction, the decimal number.
Yeah. No, like 2 by 3. I know you're saying if you can find how much she's awake, then you can find how much she's sleeping, but how would you put the equation for the 2 by 3 and 24?
Okay, okay. Maybe we don't need an equation here. Maybe we don't
Okay.
need an equation here because not all the time making some equation could be helpful because maybe we really don't need to create an equation and we really need to introduce algebra because it's we don't need any algebra here. We really
Mm.
don't need any algebra here. We can use it. We can use the simple arithmetic to solve this problem because she is awake two-thirds of the 24 hours. So we know the awake time and we know the total time of a day. And so definitely we can find out the total time of she is asleep because
Mm.
uh, two-thirds of 24 hours she is awake. And if we do the calculation, we would get a fractional number. And if we subtract the fractional answer from 24 hours, that is the time she's asleep in a day. Or we can,
Oh, okay.
this
Yeah,
is one method. This is one method. This is one
yeah.
method. But you can do it in another method. That is basically a short method. A short method that means consider the whole number as one. Consider the whole time of a day as equal to one. So she is awake two-thirds of a day, and a day is consisted of just consider it one as a whole, one. So
Mm.
if she is awake two-thirds, so definitely the she is not awake, she's sleeping, equal to 1 minus 2 by 3, right?
Yes.
1 minus 2 by 3 is the time she is asleep.
Yeah. Oh, okay.
So you would
Yeah.
get an answer, you would get an answer 1 minus 2 by 3, 1 minus 2 by 3. That is a fractional problem. 1 minus 2 divided by 3. That is basically 1 by 3. So 1 by 3 is the amount of numbers, the amount of hours, the number of hours she is asleep. So now multiply it by 24. That's simple. That's simpler. I think that's simpler. Okay, so um, okay, so they have done it in the. They have basically done it in the in the method one, but you can also use the method two, as I have told you, because they're basically just finding the amount of time she is awake. That is basically 23, 2 by 3, 2 divided by 3 into 24. This is the time she is awake. This is the time she is awake. And
Yeah.
the amount of time she is asleep, you just need to subtract this from this. You just need to subtract this from this. You got it or not?
Yes. No.
You can
I
do
like.
in this
Yeah.
method. Okay, please continue, please.
Yeah. No, I like the other method better. The 1 minus 2 over 3. It's easier.
Okay, I think that's simpler. I think that's simpler. They
Yeah.
haven't done in that way, but you can do it. Okay, so you got the answer, right?
Yes.
Okay, so the average weight of a person, the average weight of person A, B, and C is 150 pounds. The average weight of person A, B, C. What is the average? Average is the total number of elements. The total number of elements. For an example, if you consider that the person A, person B, and person C individually as an element, then the summation of the element of the parameter. Actually, I'm just trying to introduce some new terminologies maybe. So
Yeah.
average means the total 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 amount divided by the total element number. That is basically average. So the average weight of a person ABC means that means that the weight of the person A plus 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 the weight of the person B plus the weight of the person C divided by the number of total person. That is basically 3, 1, 2, 3. You got it or not?
Yes. Yeah.
Okay, that is the concept of average. That is the concept of average. And for an example, if you're not thinking about the person and the weight problem of a person, whatever it is, you just need to add them and then divide them with the total number. Add them and divide them with the total number. You got it or not?
Yes.
Okay, so this is basically this type of problems we are facing. So average will be covered in depth in problem solving in data analysis section. Okay, but I have just given you I have given you a basic introduction to average. So distance, rate, and time. So distance, you can just consider the rate as its speed. You can consider the rate as its speed because speed equals the total distance that is covered divided by the time. The total distance covered divided by the time. The rate is the speed. The rate is the speed. So there is differences between rate and there is differences between speed and velocity because speed and velocity is not the same. But just make it simple. Make it simple. Um, Speed equals distance divided by time. Speed rate equals to distance divided by time. This is just a simple equation. This is just a simple equation. And if you take this time into this side, if you take the time variable from the right side of the equation, from the left side to the equation, if you take the time from the right side of the equation to the left side of this equation, so you just need to divide it, right or not? Have you understand my point or not?
Yes. I
It is
learned this.
multiplied here. It is multiplied here. So if you take it from the left side, then you just need to divide it. Am I
Yeah.
correct or not?
Yes.
Okay. So that is basically we're just doing it shortly. But the actual thing is, if you really want to vanish the time, if you really want to vanish the time from this side, right side of the equation, then you just need to divide it. You just need to
Mm,
divide the whole, both sides of this equation, the distance side and the rate multiplied by the time side, the left side and the right side of this equation divided by time.
mm,
So in that case, the time here and the time denominator here, use your imagination. The time here, right side of this equation, and the time that was in the denominator will get crossed, will get cut off, right? They will
mm.
just got vanish because time divided by time equals 1. And then distance divided by time equals square. Actually, I'm just telling you what would happen if we just take this time from the right side of the equation to the left side of this equation.
Yeah.
Actually, I wish I had the pen tablet because it is really getting complicated.
Mm,
I promise I won't continue without my pen tablet in the next class. I promise
mm,
because it's not possible to understand. Okay, so just consider this as a formula that is distance equals rate into time, d equals rt. For an example, if you're driving at 60 miles per hour for 2 hours, you would travel a total 120 miles. For an example, if you were driving at 60 miles per hour, that is basically our rate. 60 miles per hour is nothing but the rate. You got it or
mm.
not?
Yes.
And the time spent we are driving, that is basically 2 hours. This is the time span. So this is the
Yeah.
time. So the total distance we are covering, that is d, and it is nothing but 60 into 2 hours. That is 120 miles. Okay.
Mm, yeah.
So you just need to consider the rate as the speed, and the distance is the amount which is multiplied by the speed and time. And uh, so we have just understood the equation. This is basically the equation. And now we're going to solve a problem. That is, Julia's family took a road trip in which they drove 8 hours a day and average a driving speed of 50 miles per hour. If they spend a total of 6 days on a trip, how far in total did they drive? Julia's
Mm,
family took a road trip in which they drove 8 hours a day. Julia's family took a road trip in which they drove 8 hours a day. 8 hours a day. So we are given the time and averaged driving speed of 50 miles per hour, and averaged driving speed of 50 miles per hour. So we are also given the rate. We are given the time and we're given the rate. So if they spend a total of 6 days on the trip, how far in total they drive? So first of all, we just need to find the total amount of distance they are driving in each day, and then we just need to multiply it by 6 because they're traveling for 6 days. Okay, so that is gonna be your answer. They have done the same for 1 day and for 6 days. This is the answer. You got it. Okay, interpreting variables and constants. So sometimes set word problems will not simply ask you to solve for the value of a variable, but to interpret the significance of a constant or variable. So they're just telling that you sometimes you not just only find the answer, not only the solution or the value. You also need to give explanation, an explanation for the answer, an explanation for the answer. So how does that look like? A teacher is counting up his classroom supplies for inventory. At the end of this year, T is equal to the number of textbooks in his class at the end of this year, and L is the equal to the number of laptop computers in his classroom at the end of the year. In this equation, P plus L equals 60. because, okay, t plus l equals 60. What does the number 60 represent? So t plus L equals 60 means that the total number of textbooks in his classroom and the total number of the laptop computers in his classroom at the end of the year is equals to 60. The total number of products, the total number of laptops and the number of textbooks at the end of this year in the teacher's classroom, you were just asked to find the meaning, actually the interpretation. You just need to give the interpretation of the problem A, problem B, problem C, and problem D. The product of the number of the laptops and the number of textbooks at the end of this year in the teacher's classroom, the combined total number of laptops and textbooks at the end of the year in the teacher's classroom. I think these problems are really pretty boring, and but we need to solve it. Okay, these problems are really so boring, but we both have no choice. Okay, so can you hear me?
Yes.
Okay. Um, the total number of textbooks and laptops equals T plus L. So, so they're just preferring to give you the solution, not one by one. They're just combining all the answer just in one answer. Actually, you just need to go through this. If you just do some self study, if you do some self study, then you would definitely understand what is the meaning, what actually I'm talking about, because what actually they are talking about. Because following our strategy for problems like this, do not jump into the choices before we have considered the meaning independently. T represents the number of textbooks at the end of the year, and L represents the number of laptops at the end of the year. If we add this together, we would get the sum of the textbooks and laptops the teacher has at the end of the year. That is basically what I have told you in the first sentence. In the first sentence, T plus L equals 50. That is basically nothing but the number of textbooks in his classroom at the end of the year, and plus the number of laptop computers in his classroom at the end of the year. So the product of the number, this question, and this question, you can just simply simply interpret it if you really just understand the problem statement. So the very first step to solve this type of problems, you just need to understand the problem statement. You just need to understand the problem statement. Read it, not just don't read it once, read it twice, read it thrice, as many times you really want it, as many times you really understand it. If it's not clear to you, then read it again and again, and then in the meantime you will definitely be capable of to solve this type of problem. Okay, so we have a similar problem like this. You just need to go through this. I won't tell you the exact solution. Functions in table form. Most functions you will encounter will be in the form of an equation. Sometimes, however, the set will provide the values of the function in a table. Here is how you attack a problem formatted in this way. Okay. What we have told in the previous class, that is basically our variable and the output, that is x and f of x. I introduced you with a term called regression, but we are not allowed to use the regression. The thing that we really need to do, that is basically we're gonna solve this problem as the set is permitting. The set is permitting. The linear function is because we know the input and the output is also given. We know the input and we also know the output. We know the input and we also know the output. And the statement is the linear function f is defined by f of x equals x plus b, where a and b are constants. The values in the table below represent ordered pairs for the function. Okay. I'm sorry, excuse me. What is the value of the constant b? What is the value of the constant b? So the simplest way to solve this problem, you just consider this y equals ax plus b, y equals x plus b. So this is gonna be the y value. This is gonna be the y value. Please let me use my pen. Okay. This is gonna be the y value. This is gonna be the y value, and this is gonna be the x value. Okay. Are you understanding or not?
Yes. Yes.
How clear?
Yeah,
Are you
I guess.
understanding?
Yeah,
Okay, so you can just consider this f of x as y, right?
yeah. Why?
And this is basically x.
Hmm.
So you can write this equation as y equals ax plus b, right?
Yeah, yeah.
Ax plus b. I'm just using my mouse. I'm not using my pen tablet. That's why it is looking so ugly. I'm sorry for that. So this is y equals x plus b. So what you can do basically, what you can do, that is the thing that you can do, that is, um, okay, we have y and we have x, and definitely we can find the values of a and b, because this is nothing but solving a solving a pair of linear equation, because we have two variables then. We have two variables then, because we know the
Mhm.
value of x and y, right? We know the
Yeah,
value of x and y,
yeah.
because in that case we know the value of x and y, um because
I
this is
have
the
a
y and
I
this is
have a
the x.
question.
Okay, so sure, please.
Yeah, okay. I know we have the X and Y, so you can plug in like so for Y you can do to
Exactly, exactly,
700
exactly,
equals
exactly,
8. Yeah,
exactly,
but how would you find A and B or just B?
exactly. You just need to find a and b. We are gonna get two equations, one
Okay.
equation for this and another
Yeah.
equation for this.
Mhm.
Okay, fine. Thank you. Thank
Mhm.
you. All right. Um, they have done it in a different way, but
Oh, okay. I get this. Right.
you can do it. Okay. So we have
Yeah.
some real problems. You just need to go through these problems and set math questions, practice drill. Please solve each and every single problem. At least if you cannot do on your pen and paper, then at least please try to understand what they're talking about and do use your imagination. Use your imagination. The most you will be able to use your imagination, the more you will think of a problem easily. So we have practice drill two. I'm not gonna solve these problems. These are your homeworks. If you face any kind of problem in any question, please ask me. And most importantly, they're trying to manage each and every single drill. For an example, this is the drill number two, and the problems that we have done in our example section looks quite similar as in the practice problem. The example and the practice problem are quite similar. Only the questions a little bit changed, and all the problems are solved. You got it?
Yes.
Okay, all right. So I think we are we're, we are on next section, which is heart of algebra, lines and slope. But I think we have been able to solve all of our questions. For an example, I really wanna try to look on a problem. What basically it looks like. Um, I'm just trying to give you an example. For an example, take this problem. Problem number 5. Tabitha works as a cell phone salesperson. Her pay is $10 per hour plus $20 commission for each
Mhm.
new cell phone she sells. If H, actually this is the practice problem, okay? This is one of the
Mhm.
practice problems. If H represents the number of hours she works in a given week, and C represents the number of cell phones she sells that week, which equation represents her total salary expressed in dollars before any deduction for taxes, etc., for the week? I think this is just a baby problem for you, because you are very good at algebra, as I have experienced. So I'm just trying to tell you that is, you just need to go through this statement maybe twice or maybe thrice.
Mhm.
Tabitha works as a cell phone salesperson. Tabitha works as a cell phone salesperson. Her pay is $10 per hour plus
Yeah.
$20 commission for each new cell phone she sells. If H
Mhm.
represents the number of hours she works in a given week, if H represents the number of hours she works in a given week, okay, so please just be careful about, because
Mhm.
here they are just mentioning the age represents the total number of hours she worked in a given week, and they're also asking the answer for a given week. Okay, they're also
Yeah.
asking for the answer for a given x. So you just don't need to convert. You don't need to convert from months or from days to weeks, etc., etc. It's
Okay,
quite
so
simple.
is the answer B? I'm just guessing.
Yeah, maybe. I think the answer maybe is B. So if A represents the total number of works, actually I haven't tried to solve it.
Yeah.
You're faster than me, maybe B. You're saying B is the answer, right?
I think
Okay,
maybe.
let's see. Let's see. B is the number five number problem. Okay, yeah, actually, congratulations. B is
Oh,
the answer. B is the answer. Congratulations. Okay, I don't think I really need to go through the problems, each and every
yeah.
single problem. We can move to the new section. We can move to the new section. So please practice all the problems and cross-check the problems. Cross-check the problem solutions. Cross-check your solutions from the answer section.